Hey guys, welcome to question MM415 of the Maths Methods Fortify study guide. So in this question we've got a new company, Banana, has decided to build a smartphone and sell it in stores as their e-phone. These phones are low quality and only last a limited time before the circuitry and battery stop working and the phone becomes unusable. The time from an e-phone's manufacture to the point where it is no longer usable is known as its lifespan. An e-phone's lifespan X days is a normally distributed random variable with mean 400 and standard deviation 21. Part A is a 2-mark question and says, what is the probability that any given e-phone will have a lifespan of less than 365 days? Give your answer correct in 4 decimal places. Awesome. So first things first is to recognize that obviously we're dealing with normal distribution. The question's told us that. So what we're going to need to do is use our normal CDF. All right. So we have our normal CDF, which is going to ask us for 4 things: lower, upper, mean, standard deviation. Awesome. Now our lower is negative infinity, right? Because we've got this normal distribution curve, which has a mean of 400 days and a standard deviation of 21. So 421, 442, etc. 479, blah, blah, blah. What we're looking for is the probability, 379 that should be. What we're looking for is the probability that it's less than 365. Okay, so all this area here, which is our probability. So our lower is going to be negative infinity. Our upper is going to be 365. Mean is 400 and standard deviation is 21. There's our first mark here. Our second mark comes from actually subbing this into our calculator and getting it. So what we get is the probability that x is less than 365 is equal to 0.0478. That's our second mark. So guys, that's it for part A. Let's move on to part B. Part B is a 2-mark question, and this is actually a tricky one in the sense of I've kind of designed it to kind of trip you up a little bit. So if you didn't get tripped up by it, awesome job. If you did, that's fine. It's a tricky question. So part B says, it has been 365 days since Darcy bought his e-phone and it still works. What is the probability that it will stop working in the next 21 days? Awesome. So what we're essentially saying is, what's the probability that its lifespan, so we know that it's been working for 365 days, and we're looking for the probability that it'll stop working in the next 21 days, which means that its lifespan will be less than 386. Okay, so the 365 and then plus the 21. That's our 386. So the probability that its lifespan will be less than 386 days. But we know that it's been working for 365 days, right? Which means that we have to do a given that x is greater than 365. So we're asked to find the probability that it'll stop working in the next 21 days, so that its lifespan will be less than 386. But we know that it's been 365 days and it still works. So the lifespan has to be greater than 365, which is why this is a tricky question, because you've got to interpret that given that part of it. So using our conditional probability formula, is equal to 365 over the probability that x is equal to 365. Sorry, x is greater than 365. Now the intersect between less than 386 and greater than 365 is exactly that. So from 365 to 386 over the probability that x is greater than 365. Awesome. Now that's our first mark. So we can actually use this in our normal distribution now. So what we're looking for is the probability that it's between 365 and 386, which might be somewhere here. So what we're actually looking for this time is this area in between here. So again, we use our normal CDF. It's going to ask us for lower, upper, mean, standard deviation. So our lower is 365, our upper is 386, our mean is 400, and our standard deviation is 21. What this gives us is 0.2047, which means that this bit here, it's horrible, equals 0.20, didn't mean to do a 0 there, 2047, over the probability that's greater than 365. Now we know from part A that the probability that it's less than 365 is 0.0478, which means that the probability that's greater than that is 1 minus 0.0478. Right, because everything greater than that has to equal to 1. Awesome. Now we can just sub this into our CAS, and what we get is 0.2150. And that is our second and final mark for part B, guys. Let's move on to part C. Now part C is a 3-mark question and can be quite tricky if you're not used to them, because this is a stats question, which is the new study design, so there's potentially not that many practice questions out there for this. So CI, 3 marks. Now it says, Banana is getting a lot of complaints about the short lifespan of their ePhones. They want to run some tests on a sample of ePhones so they can make sure they are not producing faulty phones. They take a sample of 150 phones to test from various stores around Melbourne. For samples of this size from the, actually I'm just going to write that down, so 150 phones. For samples of this size from the population of ePhones with mean lifespan 400 days and standard deviation 21 days, p hat is the random variable of the distribution of the sample proportion of ePhones with a lifespan of less than 365 days. Okay, so there's a lot going on there, but the biggest thing to recognize is that our p hat is our proportion of phones that last less than 365 days. That's what I would get from that. Now, part I says find the probability of p hat is less than or equal to 0.02 given that p hat is less than or equal to 0.04. Correct to 4 decimal places, do not use a normal approximation. Awesome. So first things first, whenever we deal with probabilities with proportions, what we want to actually do is change our p hat into an x value, okay? Because we're going to have to do that for binomial distribution, and you'll see why in a second. So we need to change our p hat. So we know that p hat is equal to x over n, where x is our successful attempts and n is our total attempts or our total sample. Now we know that in this case p hat is 0.02. We don't know our x, that's what we're trying to find. We know that our n is our total sample space, which is 150, which means that x is equal to 3 in this case. And in our 0.04 equals x over 150 again, which means that x is equal to 6 here. So that means that this here is equal to the probability that x is less than or equal to 3, given that x is less than or equal to 6. Okay, so that's our first step, and that's worth a mark in itself. Because why we do that is we don't know how to deal with this. We can't deal with proportions, it's too difficult. Whereas with x values, we can deal with it, okay? So, from here, we can rewrite this as the probability that x is less than or equal to 3 intersect x is less than or equal to 6 over the probability that x is less than or equal to 6. So this is just a generic given that formula, a conditional probability formula. The intersect between x is less than or equal to 3 and x is less than or equal to 6 is just x is less than or equal to 3. Okay, so if you think about this on a number line, I've done this a couple of times, but if you haven't seen it, it's fine. Now, we've got probability x is less than or equal to 3, so everything from here. And then we've got probability x is less than or equal to 6, so everything along here. What's the intersect of these two things, or the common area? Everything from this point onwards. So x is less than or equal to 3. Over the probability that x is less than or equal to 6. Awesome. So now, what we want to do is use our binomial CDF, okay? Because each phone can either last less than 365 days or more than 365 days. And whether one lasts less or more doesn't affect whether the next one lasts less or more either. Okay, so they're all independent events, independent trials. We've got a certain number, which is 150 in this case, and each one of them has their own probability. So from here, what we're going to do is use our binomial CDF, because binomial is the probability that we're now dealing with. We are never, whenever we deal with this, we're never dealing with normal. Even if this whole thing is normal, this bit over here is always a binomial. So we have for our top one, we have our lower, upper, mean, standard deviation. So our lower in this case is 0, because we can't have less than 0 being like less than 365. Lower is 0, upper is 3, because that's less than or equal to 3. Mean is 1, sorry, we're not looking for that, we're looking for n and p, my bad. N and p. N is 150, because we've got the total number of phones, and P is actually 0.0478, which is what we found in part A. Okay, so the probability that a phone lasts less than 365 days is 0.0478, and we are now needing to recognize that we have to bring that back. Okay, so what this gives us in our calc is, where are you? 0.0687. So that's this bit. So it's 0.0687 over probability that's less than or equal to 6. So actually I didn't need to do that. So now we need to do our 6. Okay. So our lower for this one is 0, upper is 6, n is still 150, and p is still 0.0478. Now what this spits out is 0.4207, and this is our second mark, getting that, 0.4207. Subbing all this into your CAS, what you get is 0.1632. So therefore, because we've said that it's this, so therefore probability that p hat is less than or equal to 0.02, given that p hat is less than or equal to 0.04, equals 0.1632. And that is your third and final mark for this question. Guys, let's move on to part CII. Now part CII is a 2-mark question. 2 marks II. And says, Banana finds that 10 of the sampled phones have a lifespan of less than 365 days. What is the margin of error for this test in a confidence interval of 90% for this proportion? Give your answer as a percentage correct to 1 decimal place. Awesome. So, first things first is to say that the margin of error is equal to z outside of p hat 1 minus p hat over n. Now, you can do this directly onto your calculator, but you need to do the whole working in order to get your full marks, all right? So let's just go through the manual working. So we know what our p hat is going to be, we know what our n is, but we don't know what our z is going to be because we're dealing with a 90% confidence interval, okay? So that's our important part here. What a 90% confidence interval means is that, I'm actually just going to get rid of this. What a 90% confidence interval means is that between two values, negative z and z, so z is this z here, where our mean is 0, standard deviation is 1. What it means is that 90% of the data lies between here. Okay, so that's what a 90% confidence interval is. So we need to use this in order to find our z value, okay? So let's do that. So 90% lies between here, and because this is symmetrical, it means that 5% lies above and 5% lies below, which means in order to find out what this z value is, we can use the area to the left of this, which is actually in fact 95%, right? Because it's total, 90 plus 5, in our inverse normal calculator, and it'll give us our z value. Awesome. So I'm just going to double check this on our CAS. So we go menu 553, area is our area to the left, which is 0.95 in this case. Mean is 0, standard deviation is 1. So we get 0.95, which gives us 1.64485. We want to try and be as accurate as possible as we can here, just so that we don't kind of stuff up any rounding up here. So we know that our z value is 1.64485. So we can say that that's actually our first mark. So we can say that our margin of error is equal to 1.64485 outside of root p hat 1 minus p, p hat over n. Now, what is our p hat? Well, we know that the proportion of phones that have a lifespan of less than 365 days in this sample is 10 out of 150. Okay, the question tells us that. Banana finds that 10 of the sample phones has that lifespan, and the total is 150. So 10 out of 150 outside of 1 minus 10 over 150 over our sample size, which is 150. Just make sure that we have that square root affecting both. Now what this gives us is 0.0335, which equals which equals a margin of error of 3.4 Now, if you've got 3.3% in your answers, that was a typo on our part, and that is incorrect. So it needs to be 3.4%. That's your second and final mark for part CII. Guys, let's move on to part D. So part D says, Banana decides to release a new version of the ePhone called the ePhone 2.0, which has a better lifespan in an attempt to lower the amount of complaints they receive. The lifespan of an ePhone 2.0 is a continuous random variable y days, which is modeled by the probability density function f of y equals 3 y take 500 squared over 1 million from 400 to 500. What is the average lifespan of an ePhone 2.0? Well, whenever we deal with average, what we're talking about is our expected value, right? And the way that we find our expected value is the integral from our lower to our upper of x times f of x dx. That's our mean formula for continuous density functions. Now, from our lower to our upper is 400 to 500 of x, but in this case we're dealing with y, so we'll just replace it with a y. We're timesing that by our function, which in this case is 3 y take 500 squared over 1 million dy. Awesome. And because this is a 1 mark question, we can just sub this into our CAS. What we actually get is 425 days mean. And that's our first and only mark. So guys, let's move on to part E, which is also a 1 mark question. And says, what is the probability that any given ePhone will last, any given ePhone 2.0 will have a lifespan of less than 365 days? So a little bit of a trick question. But the key here is we're looking for probability that y is less than 365. Now, according to this probability density function, an ePhone 2.0 has a minimum lifespan of 400, right? It can't go less than 400, which means that the probability that it's less than 365 is 0. So that's our first and only mark for part E. Guys, let's move on to part F. Part F is a 2 mark question. And says find the value of m where m is the median lifespan of an ePhone 2.0 correct to the nearest day. Awesome. So whenever we talk about median, what we're talking about is the fact that our median is the point that has half of the data on either side of it under the graph, right? So the area up to the median is 1/2. So 1/2 equals our area from 400 to m. So the lower bound to our median is 1/2, okay, of 3 times y take 500 squared over 1 million dy. And then we can just evaluate this. So what I would do is actually sub this into my CAS and just rewrite the next section using that. So our next part is y take 500 to the power of 3 over 1 million from 400 to m, and that's equal to 1/2. Now we can just sub in our values as normal to evaluate this. So we get m take 500 cubed over 1 million minus 400 take 500 cubed over 1 million. That's equal to 1/2. Awesome. So we're gonna, that's actually our first mark. We're going to multiply both sides by 1 million. So what we get is 500,000 equals m take 500 cubed. And then 400 minus 500 is negative 100. And I'll just actually rewrite this. So take away negative 100 cubed. And what we get here is then m take 500 cubed plus 1 million. It's equal to 500,000. Awesome. Now I know these are big numbers, but we just have to deal with them. So then solving for m, we can rearrange this, and what we get is m equals 421 days, which is our second and final mark for MM415, guys, and that wraps up that whole question. So guys, if you have any questions about any of this, please let me know in the comments below. But otherwise, thank you very much for watching, and I'll see you in the next video.